just the study of ratios. Technically, we can talk about sides and angles, but to start, we're just going to talk about the study of ratios of sides in right triangles. Okay. There are 3 of these ratios that we're going to look at in this class. Okay. There are actually a lot more than 3, but we're only going to look at 3 in geometry. Right? They are sine, cosine, and tangent. Right? So the way that they are abbreviated, okay, is SIN for sine, COS for cosine, and TAN for tangent. Right. So these are so important that each of them gets their own button on the calculator. Right? So you can break a square up in right triangles. I don't know what it was asking. I didn't see the question. All right. So if I'm looking at a right triangle, sine is defined as the ratio of the leg opposite to an angle over the hypotenuse. For example, okay, if I'm looking at this triangle over here, and I want to give the sine, cosine, and tangent of angle A, the first thing I want to think about is labeling the 3 sides of the triangle as the opposite side, the adjacent side, and the hypotenuse. Okay? So in this triangle, with respect to angle A, side A would be the opposite side. Side B would be the adjacent side. Okay? Adjacent means right next to. And then C would obviously be the hypotenuse. So all we're doing for sine, we're saying that that is defined as the opposite side over the hypotenuse. So in this case, we're going to say that that's A over C. So the sine of A is A over C. Cosine then is defined as the ratio of the leg adjacent to the angle over the hypotenuse. So for this triangle, the leg adjacent is B, and the hypotenuse is C. So the cosine of angle A would be B over C. And then our third one, tangent, is defined as the ratio of the leg opposite over the adjacent. So for this one, that's going to be A over B, the opposite side over the adjacent side. Now, for the same triangle then, I can give the sine, cosine, and tangent for the other angle, for angle B. Okay? We will never talk about sine, cosine, and tangent for a right angle because that has kind of special properties. So we're just looking at the 2 acute angles. So now, with respect to this angle, this side is now the opposite side. So now, right now, we're just kind of talking about the definition of these functions. So we'll get to using them here in a second. So, and then with respect to B, this is now the adjacent side. The hypotenuse doesn't change, right? The hypotenuse stays the same. But if I'm looking at, with respect to this angle, this is the opposite side, and this is the adjacent side, right? So, the sine of angle B, if I'm looking at opposite over hypotenuse, is actually B over C. Yeah, so one thing that we'll actually end up looking at a little bit later, maybe proving if we have time, is that in a right triangle, the sine of one of the angles, we can call it angle B here, is equal to the cosine of the other angle. Right? Here we've got B over C, here we've got B over C. Okay. So then for the cosine of B, cosine is the adjacent side over the hypotenuse. So in this case, for angle B, that's going to be A over C. And then for the final one, for tangent of B, opposite over adjacent is going to be B over A. So yeah, so for tangent of the two angles, it's just the reciprocal of itself. Right? But for sine and cosine, kind of one of the acute angles is equal to cosine of the other one, and vice versa. Right? Cosine of angle B would equal sine of angle A. Okay. Questions so far? All right. So to remember this, there is a little trick that we use. So, katoa.
I was looking at that on the wall. What does that mean? It's scary.
So katoa. It's not that scary, right? It's just a way to remember what these three trig functions tell us. Okay. So I'll write it out over here. So means that sine is opposite over hypotenuse. That's the definition of sine. No, so don't ever call them sin, cos, and tan. It's sine, cosine, and tangent. Sorry. That's all right.
So why do they put S in? If it's just the meaning of sine, why wouldn't you put sine?
Sine is opposite over hypotenuse.
Then why do they call it sine, not just this?
Because this is an abbreviation for sine is opposite over hypotenuse. The function
He's
is
talking about like
No. I'm saying like, why do we have two meaning the same thing? SOH means sine.
It's an
That shows you the definition.
Yeah, it just this tells us the definition of sine. Right? This isn't saying this is sine, right? This is sine means opposite side over hypotenuse.
Oh, okay.
Okay. Then ka. If sine means, or if sine is opposite over hypotenuse, what is ka going to stand for? Cosine is adjacent over hypotenuse. So we usually end up just abbreviating opposite to OPP, hypotenuse to HYP, bless you, adjacent to ADJ. Right? Then our final one, TOA. What's that going to stand for? Right. Tangent, opposite over adjacent. Alright. Questions so far? Alright, so let's take a look at some actual numerical values then. Alright, so in number 1 here, first we want to do the sine, cosine, and tangent of angle A. So I'm going to label the triangle. Right? With respect to angle A, the 5 is the opposite side, the 12 is the adjacent side, 13 is the hypotenuse. So sine is opposite over hypotenuse. Sine is going to be 5 over 13. Cosine is adjacent over hypotenuse. So cosine is going to be 12 over 13. And tangent is opposite over adjacent. So 5 over 12. So eventually we're going to use this to solve for missing pieces in triangles. It's not too bad. So yes, Clayton just asked if we can simplify, should we simplify? Yes. None of these fractions can be reduced, but I think in the next one we can reduce fractions. So yes, whenever you can reduce fractions, reduce them. Okay, so let's finish this one out and do C. All right, so now with respect to angle C, this is the opposite side. This is the adjacent side. Hypotenuse is still the hypotenuse. So the sine of angle C, opposite over hypotenuse, is 12 over 13. Cosine of angle C, 5 over 13, and adjacent over hypotenuse. Yeah, these end up just swapping. And tangent of C, opposite over adjacent, is 12 over 5. Right. Yep.
So it's not possible to be angle B because the opposite would be the hypotenuse.
Right. So we don't really talk about trig functions for the right angle because the opposite side from that is the hypotenuse. So we can't really write these ratios like that. All right. Any other questions so far? All right, then let's watch a little video here.
To solve the hypotenuse.
Yes, we're going to come back to that here in just a second.
No one likes that. God. So is it gonna tell us like you know, the determine if it's a 36? Yeah, because the opposite and adjacent sides aren't congruent, so it would be a 36.
Well, yeah, not necessarily. But we can always use Pythagorean theorem to find the third side. This is actually also a Pythagorean triple.
3, 4, 5.
It's a multiple of 3, 4, 5.
So it's 3, 4, 5.
Yep.
Oh.
All right.
Are they? Oh,
All done? Sweet. All right. This is a little cheesy. I'm just warning you ahead of time.
Once upon a time, there lived a Native American tribe, the Pythagoras tribe. The Pythagoras tribe was located on the opposite side of the Archimedes forest and adjacent to Triangle Mountain. In the middle of the tribe was the pond of trigonometry. The Pythagoreans were very interested in the
the shapes of the world around them. They especially loved triangles. There was a boy who lived in this tribe who was very good at solving math problems. One day, he became very upset while trying to find the angles of a right triangle. He decided to take a walk up through Hypotenuse Trail. The more he walked, the more frustrated he became. He soon became filled with rage and kicked a rock. Ouch! It hurt so bad that he forgot all about math and ran down the trail to the pond, where he soaked his toe. As he was soaking his toe, he realized how to solve his math dilemma. In order to find the angles of the triangle, one has to look at the trigonometric ratios: sine, cosine, and tangent. He ran back to the tribe to explain what he had figured out. Everyone was so impressed that they called him Sohcahtoa, because he had to soak his toe, which is short for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. He later became Chief Sohcahtoa, the grandfather of trigonometry.
True story. No, obviously that's not a true story. Alright, so Chief Sohcahtoa had to soak his toe to realize the trigonometric ratios. You don't know? Alright, so let's take a look now at the next couple of problems. I can reconnect this here. We are, right. So on number 2 here, we are missing a side. How can I find the third side of a triangle? So, if we recognize this, we have to do actual math now, okay? If we recognize that this is a Pythagorean triple, that's going to save us a little bit of time, right? This is a multiple of a 3, 4, 5 Pythagorean triple, right? So, if we think about, well, if this side is 3 and 4, I'm dividing 9 by 3, I'm dividing 12 by 3. That means this side would end up being 5 times 3, or 15. If you don't recognize that this is a Pythagorean triple, you can always use Pythagorean theorem. So we can set this up as 9 squared plus 12 squared equals c squared. Okay? Square these, so 81 plus 144. Add those together and we get 225. Take the square roots and we get 15. Okay? So then, once we have that third side, then we can write our trig ratios. Okay, so the sine of angle. So yeah, we're starting with W. So let's label the sides with respect to W. Opposite, adjacent, and hypotenuse. So the sine of W. I guess I erased my 15 there. The sine of W opposite over hypotenuse would be 12 over 15. And we want to reduce that if we can. So we can reduce 12 over 15. That would just be 4 over 5. For cosine, adjacent over hypotenuse would be 9 over 15. And again, we can reduce that to 3 over 5. Tangent of W, opposite over adjacent, 12 over 9, which we can reduce to 4 over 3. Then for our three trig functions of x, we want to do the same thing. So with respect to x, this is now the opposite side. This is the adjacent side. So the sine of x, opposite over hypotenuse, 9 over 15. That would reduce to 3/5. Cosine, adjacent side over the hypotenuse, is 12 over 15, which would reduce to 4 over 5. And tangent, opposite over adjacent, 9 over 12, which would reduce to 3 over 4. Alright. Questions?
I think I recognize that cosine. Oh wait, you already said it. Like the cosine W and cosine X are the same.
Yeah, so the cosine of one angle is equal to the sine of the other one, the right triangle, and vice versa. The sine of this angle is equal to the cosine of this angle.
And tangent is opposite.
Right. Tangent of this angle is the reciprocal of tangent of this angle. Yep. Right. So, and we'll look at practice error questions towards the end of the chapter, but most years on the air test, there has been a question where they just give you a right triangle, like this, and they give you all the sides, right? So they could say, like 5, 12, 13, and they say, here's some angle, give me the cosine of theta, right? That's been an error question. So, I guess that's something we haven't really talked about, is the variable theta, right? A lot of times, and we'll look at this as we get into trigonometry here, Greek letters are used as variables for angles. So like alpha, beta, theta are the most common ones. Okay? Theta is probably the most common variable you'll see for an angle. Okay, but it's just the same as if there were an x there. And it's just a variable. So, I mean, a question on the air test would just be, give me the cosine of this angle. Well, it's exactly what we've been doing, right? So the adjacent side over the hypotenuse. The answer would be 5 over 13, right?